And so today I'm gonna be doing the chemistry week 5 CA quiz. It's mostly calculations this week, and let's start. So you have 3 moles of H2 are mixed with excess N2. So keep in mind that N2 is excess. When equilibrium is established, 1.5 moles of NH3 are produced. What is the percentage yield? So what it told you is that you have 3 moles of H2 and that you have when equilibrium is established, you will have 1.5 moles of NH3 produced. But when you look here, so 1.5 is your actual yield, because we know theoretical yield or percentage yield equals actual yield over theoretical. I'm just gonna write theory yield. Y is yield. So actual yield is given, it's 1.5. Theoretical yield is what we find. So when 3 moles are used, we have 2 moles being produced and then 3 moles. So 3 times 2 divide 3, you're gonna get 2. So 2 is your theoretical yield. Now what you do is 1.5 divide by 2. Oh, by the way, this equation is times 100. I forgot to add that, my bad. Times 100, you're gonna get 75%. And that's how you solve for theoretical yield. Now, let's move on. Okay, so they're asking here, which of the following electronic configurations respond to noble gases? What we know is that a noble gas, it always ends with an 8. So if you see anything ending with an 8, most likely it's a noble gas. Some people might say, oh, if it ends in a 2, it's also a noble gas. That's in one case, when it is 2. That's your entire electronic configuration. When it's helium, which has 2, then, yeah, but other than that, it has to end with an 8. And either way, when you add them, you're going to find this is equal to 10 and this is equal to 18, which when you look at the periodic table, you'll find both of these at the last group. So they're both noble gases. Moving on. Here they're asking us, how do you write the configuration for sodium? Since it's 11. Now look, what we know, the first number always has to be 2, because the first shell can hold a maximum of 2. Second shell, third shell, fourth shell can hold up to 8 each. So first one, we know it's 2. Now we subtract the 11 from the 2, we're left with 9. Second shell, we said it can fit how much? 8. So subtract the 8 from the 9, you're going to be left with 1. So third shell, you're going to have 1 left. And that's your configuration. Now, moving on. Okay, this is old. This is, you're adding an acid to a carbonate. We know that you're going to have effervescence of bubbles and that you need to find the products CO2 and H2O always in the net ionic equation. Here it's ammonia, again, old material. We know that you need a pressure of 200 atmospheres and a temperature of 450 for the Haber processes, and you use iron, and catalysts always increase rate but have no effect on yield whatsoever. So now that's it. Now moving on. Okay, this is memorization. Our room temperature and pressure, just take the first 3 letters, RTP, abbreviated as standard value of 25 degrees Celsius and 1 atmosphere. It's always 1 atmosphere, and the temperature differs. STP it's 0 if I'm not wrong, RTP is 25. Again, another memorizing question. The first ionizing energy is the minimum energy required to remove the most loosely bound electron, because you can't move protons nor neutrons. And when you remove this electron, you're going to form a neutral gaseous state or atom. Moving on. Okay, so this question, it's telling you have the empirical formula of a compound X. This is your empirical formula. So CH2O. If the molar mass of a compound that we do not know is 60, this is its molar mass. Now, what is its molecular formula? What we know is that these are like multiples of the empirical formula. So you just have to multiply the subscripts to make any molecular formula. So first of all, what we do is we have to find the molar mass of this compound. C is 12, H is 2, O is 16. Add them together, you're gonna get 30. So how much did you multiply to get from 30 to 60? But times 2. So you do the exact same thing. This all to 2, so it becomes C2, H4, O2. And that's your final answer. Now, moving on. So here you have a hydrocarbon is 75% of carbon by mass. Find its empirical formula. Now listen, I'm gonna give you an easy way to use in the exam, but this way can only be used if you have two elements inside your compound. And here you have a hydrocarbon, which is H and C. Only two elements. So you do moles of H over moles of C. And then you find the ratios. So moles of H means you do how many... Okay, so a hydrocarbon is 75% carbon. 75% carbon means you have you're gonna take it as if it were 75 grams of carbon. You're gonna take it as if it was. And then you're gonna do 100 minus 75. Let me do it on my calculator so I don't mix up. 25. So then you're left with 25 grams of H. We're gonna take it as if it were grams. And then you're gonna divide these by your molar masses of each compound, of each element, to find their moles. So it's 25 divided by 1 over 75 over 12. Now let me get my calculator because I forgot to get it before starting recording, and I'll solve it really quick. Okay, so when you put it in your calculator, you're gonna get 4. What is 4? 4 is 4 over 1. It's the same thing. So what this means is that the amount of hydrogen atoms are 4 and the amount of carbon atoms are 1. So C is 1, H is 4. And that's the easiest way to solve it, a trick way to solve it if you have only 2 elements. Now let's move on. Here, redox, non-redox. Here we have the numbers of oxygen. You had 3 here, you had 3 here. Since there was no change in the number of oxygen, this is not redox. Redox means change. 1 O here, 1 O here, not redox. Here we're gonna take it by oxidation number. Cu has an oxidation number of 0. Here it has an oxidation number of 2. And here O also has a 0 and 2. So it changed from being a 0 to a 2. So there's a redox. Zn again changed from being 0 to having a value, which is again 2. So then you have redox. Anytime there's a change in either whether it be number of oxygen atoms or number of or oxidizing number, there is redox. No change, no redox. Here, these questions are really easy. You first take negative 2 to be O2. This one, we just put it immediately. Multiplied by subscript becomes negative 4 equals 0. X, so x minus 4 equals 0, so it's 4 and negative 2. H and O, we know they're 1 and negative 2. Now we do 1 plus x minus 8 equals 0. And then you get this 7. And then O again, negative 2. And now we have x minus 8 equals negative 1. X equals 7. So Mn is 7. And negative 2 is O. I did this question really fast because we did it a million times in previous AMSs and periodics. So let's do this question now. Hydrogen gas reacts with a carbon monoxide gas to produce methanol as shown in the following reaction. When you have 0.5 tons of H2 gas reacting completely with the CO gas, the amount of methanol produced was 3 tons. They want, first of all, how much is the theoretical yield and how much is the percentage yield, because percentage yield equals actual yield over theory yield times 100. So we know our actual yield is 3 tons. So we're going to put it aside in our equation. So 3 times 10 power 6 because we need to get the percentage yield later. over what we're gonna find this times 100. When we find this, I'll put it in. So what we do is, you have 0.5 tons. So 0.5 times 10 power 6 tons of H2 gas. Here you have 2 moles of H2. H2 has a mass of 2, so 2 times 2 is 4 grams. Because, by the way, you converted the tons to grams. So 0.5 times 10 power 6 grams, and 4 grams is the given, because we're doing RRGR. And now we need to know how much methanol was produced, how many tons, or grams, and then you convert it to tons. We know methanol, we find its molar mass, and it's C, which is 12 plus 4 H's, so plus 4, plus 1 O, which is 16, you're gonna get 32. So you have now 0.5 times 10 power 6 times 32 divided by 4. Do that on your calculator. You're gonna get 4 with 6 zeros. So 4 times 10 power 6, which means 4 tons. You just take the first number when you want to convert it to tons. Now, what you do next is you take your number 4 times 10 power 6, you put it in your percentage yield equation. And the times 10 power 6s are going to cancel with each other. You're left with 3 over 4 times 100, which is going to give you 75%. And that is it. Now let's move on. Here we have another calculating question. A student wanted to find the maximum mass of aluminium oxide produced when a sample of 0.8 moles of aluminium reacts with excess O2 gas. The chemical equation that takes place is represented below. They want the mass of this produced, so how much grams? Here we need to say that we have 2 times Al2O3 has a molar mass of, wait, let me just find it really quick. O2, if I'm not mistaken. So you have, it told you have 0.8 moles of this aluminium reacting with excess. You don't need to find excess and limiting here because they told you O2 is excess. So in the equation, the given is 4, the reacting is 4, and the given is 0.8. So you do 2 times 102 times 0.8. And then you divide it by 4 because you're cross multiplying and then dividing. So from here to here, multiply, then here to here, divide. And you're gonna get 40.8 grams. And that's it. Now moving on. Here we have chapter 4. So we have molten calcium fluoride. When it's molten, we know that at the anode and at the cathode, you're gonna find the elements themselves. So since it's CaF2, this is the cation. So the positive ion, it's gonna go to the cathode because positive cations go to the cathode, which is the negative electrode. And F2 is the negative, it's the anion, so it's going to go to the anode, which is the positive electrode. And that's how you find it. And now for the half reactions, since Ca is going to the cathode, it's undergoing reaction. So they're asking you what happens at the, I don't like using negative electrode, cathode. Cathode is red fat cat. At the cathode, you undergo reduction. So Ca, calcium, is gonna undergo a reduction. In reduction, you have to remember reduction, reactants. So in reduction, you're gonna find the electrons at the reactants. So you're gonna do your ion, Ca2 plus 2E minus, it's gonna be the same as the charge, will give you calcium. Now at the positive electrode, aka anode, what you're gonna find is oxidation. So oxidation means that you're gonna have your electrons in the products. Again, we're gonna start with our ion, so F2F minus. This is different because it's a halogen or whatever. So now it's gonna produce F2, and your 2 electrons are gonna be in the products because it's oxidation, and it's losing. It's gaining. It's losing electrons, so it becomes positive. Yeah. So now that's it for this question. Now let's move on. Okay, so here you have concentrated KBr. When it's concentrated, it means whatever is at the anode is gonna be you can get your halogens at the anode. You don't have to get O2. If it's dilute, like in these 2 examples, the product at the anode is gonna be O2 without immediately. Now, KBr, we know that H2 is gonna win KBr because we have KBr and you have H plus and OH minus in your solution. K and H, which one's stronger? H is stronger, so H is gonna win and go on to the cathode. And between Br and OH, we know that Br is stronger, so it's gonna win and move on to go to the anode. Since it's a concentrated solution, it can. Now, in our next one, we have dilute NaCl. Na and H. H is stronger, it's gonna win. The only one out of these that can win is Cu. Cu is the only thing stronger in this example. Stronger than H. So Cu will go on to the cathode. Now Cl and O. Usually Cl would win, but since it's dilute, O2 immediately wins. And SO4, and between OH and SO4, O2 either way would have won if it was concentrated or dilute. So moving on. Okay, so here we have another calculating question. 0.25 moles of Cu react with how many decimeter cubed of O2 at STP? So you have 0.25 moles reacting, that's your given ratio, and here your reacting ratio is 2. With how many moles of O2? O2 will have at STP, so it's 22.4 decimeter cubed, and you need to find how much decimeter cubed they will be producing. What you do is 0.25 times 22.4, then you divide that by 2, which you're gonna get equals to 2.8, which is your answer. Now let's move on. Okay, so here we need to find limiting reagent and excess reagent. So what we do is, they gave us 1 mole of H2 and 0.25 moles of O2. So you're going to take 2 moles here and 1 mole here. You're going to take 1 mole here because this is what's in the question. So here 2, and here, since there's nothing beside it, it's immediately 1. And then 0.25. You're going to split it into 2. 1 divided by 2, you're going to get 0.5. 0.25 divided by 1 is 0.25. 0.5 is bigger, meaning this is the excess reagent, and the limiting reagent is the smaller one. They're asking you which one is excess. This one's excess, so H2 is in excess. Now, moving on. Okay, so here we have to find masses of carbon and hydrogen using the mole ratio. So 100 grams of hydrocarbon, only containing carbon and hydrogen, 20 grams of hydrogen, 80 grams of carbon. What's the mole ratio of hydrogen atoms to carbon atoms? So you want the mole ratio. What does that mean? It means you need to do the method I told you above, or before. So what you do is, because it's out of 100 grams, moles of H over mole of C. So 20 divided by how much is the molar mass of one hydrogen? It's 1. Over carbon, it's 80 grams is the mass given, over molar mass, which is 12. When you're going to put that into your calculator, you're going to get an answer of 3. So hydrogen has 3 to 1. So H to C is 3. Okay, so here we have another mole question. Here you can't do that method because that was only for when you had 2 elements in your what's it called? Whatever it's called. Here you have 3. What you do here is you have to look at all your moles. Okay? Then you're gonna find which one is your least amount of moles, which element has the least amount of moles. Between 0.96, 0.24, and 0.48, of course it is 0.24, and that is for carbon. So what you're gonna do now is you're gonna take all your mole ratios. So for hydrogen, you're gonna do 0.96 moles divided by the 0.24. Then you're gonna do for carbon 24 moles divided by 0.24. And then for oxygen, 0.48 divided by 0.24. Here you're gonna get the answer to be 4. Here it's gonna be 1. Here it's gonna be 2. So now you need to write it in C first. So C has 1. So you don't write for it a subscript. C is gonna stay the same. Then you need to write H after it. H will have a subscript of 4. And O will have a subscript of 2. And that is it. So C, H4, O2. And that's how you find it. Now, moving on. Okay, so these are really easy. So sodium has 11. We already explained how to do it. First shell will always hold 2. Second shell, you fill it out with 8. And then you're going to be left with 1. So that's for sodium. What this means, if you have 1, 2, 3 numbers, that means you have 3 shells. Meaning it's in period 3. And then you look at the last number, which is 1. Which means it has 1 valence electrons. Meaning it belongs to group 1. Now, it's really easy. Moving on. Here you have electron configuration of carbon 2, 4. So you look at the last value, that's your valence electrons, and carbon is in group 4. Moving on. Okay, so here you have oxygen has an atomic number of 8. Electronic configuration of oxygen will be first shell 2. Second shell, you need to do 8 minus 2. How much is left? 6. And that's it. You didn't fill out the second shell. So that's your configuration. Moving on. Sodium has an atomic number of 11. You need to write for sodium ion. So look. So 2, 8, 1. That's sodium. Now look. For all metals of group 1, they're gonna lose 1 electron. If it loses 1 electron, because it wants to achieve the configuration of the nearest noble gas to it. And to sodium, the nearest noble gas would be neon with an atomic number of 10. So it wants to achieve that. So what it's gonna do, it's gonna go kick out the 1 and share it with somebody else. Or give it to somebody else. And it's gonna be 2, 8 like neon. A little hint, whenever you have ions and you need to write their configuration, it's always gonna look like at least 1 configuration of some noble gas. Let me show you the next example. It's an ion here. So sulfur has an atomic number of 16. So 2, 8, 6. Now it told you that it's S2 minus. 2 minus means you're gonna take these 2 and you're gonna add them plus, since it gained 2 electrons. So this, your 6, you're gonna add 2 to it, it becomes 8. And that is it. 288, which is 18, which is like argon. It matches argon's configuration. So this is it. Now let's move on. Here, these are old material. When you add a white precipitate, you need sulfate. Sulfate is not soluble with calcium and barium. And whenever you add an aqueous solution, what ion do you add to sodium chloride? Chloride, Cl. It turns white when you add Ag plus to it. Br, bromide, turns creamy when you add Ag to it. Now, moving on. Okay. Whenever you see lime water milky, carbonate. Pungent smell, moist litmus paper blue, ammonium. Then moist litmus paper to blue when heated. Whenever you see aluminium powder and heating, nitrate. And then choking odor upon addition of acid, choking odor, sulfate. Sulfite, not sulfate, sulfite. And that's it. Now, here they're asking us find the OH concentration. So we know we do 10 power negative 14 over the how much H ions you have. They told you your pH is 5.36. So then your H concentration would be 10 to the power of the negative of this. So negative 5.36. So 10 power 14 over 10 power negative 5.36 is going to give you 2.29 times 10 power negative 9 when you do it in your calculator. Now, on our last question, it's a question about sulfuric acid. They're telling you SO2 plus O2 gives you product A. What is product A? Memorize it, SO3. Now, we know our conditions are 2 atmosphere and 450 for the contact processes, and catalyst vanadium 5 oxide. Hope you understood everything. Have a great day. Bye.